Good morning, everybody. All right, we're going to jump into 10-6 today. And in 10-6, we are talking about secants, tangents, and a few other pieces. We'll start off, as always, doing a couple 10-5 review problems. So determine whether BC is a tangent of the given circle. This is right here. And remember, tangents are always going to make right angles with radii. So this 6 and this need to be at a right angle. So this is supposed to be a right triangle. If you remember our special right triangles rule, this one does work out. If not, you can go try this as 6 squared and then square 6 root 3. And you should get 144 square of 12. So we need to just check if this is a right triangle. We do something similar. We do 8 squared plus 6 squared equals 9 squared. And this time it wouldn't work out. Hopefully this all makes sense. I encourage you to try these on your own. Make sure you've got them as just like a little 10-5 refresher. A problem like this, we have a circle and two tangents, S to L and S to K. And if since these are tangents coming from the same point, we know 3x minus 3 and x plus 7 should be the same length. So we'll set them equal to each other, solve it, and we should get 5. 5 plus 7 is 12. 5 times 3 is 15 minus 3. It is also 12. They should be the same length. That's what we're solving for. So what we're going to do today is talk about secants. And all a secant is a line that intersects a circle at exactly 2 points. So we talked about tangents last time. Let's call this one actually. Well, this will be our secant. It's hitting at 2 different points, and there's really only 3 options. There's only 3 options. You can hit the circle once, twice, or not at all. So you can either hit once, twice, or not at all. So if I want to draw another secant, I could just do any sort of line through here. Any sort of line through here that hits the circle once and twice. So a tangent hits the circle one time, a secant hits it twice. It goes through the circle. It can go really close to the edge, it can go through the middle, but a secant is like a tangent, but it'll go through the circle. Once again, you only have 3 options. You can miss the circle, you can hit it once, or you can hit it twice. And that's all a secant is. Here is our new theorem. Don't worry about the proof below. You can use that to help you understand it, but the theorem is what we want. The theorem is saying if 2 secants or chords intersect in the interior of the circle, it doesn't have to be the center, but it could be, then the measure of an angle formed is 1/2 the sum of the measure of the arcs intercepted by the angle and its vertical angle. So we have measure of angle 1 is 1/2 AB, CD. AB, CD. Similar for 2. So let's go deeper dive. What this is saying is if I have any kind of secant, I have a circle and 2 lines cutting through. Let's do them in orange. We'll say one right here, and let's say one right here. In this, if we were in class, this would be a time where I would ask you to, someone to give me one of these angles. So let's pick, how about this one? We'll call that X. We'll give this point A, point B, point C, and point D. So X is right here. It is that angle close to that inside of the circle. If I wanted to find what X is, that's this right here, what I'm going to do is I need these two pieces. So I have, choose a different color, A to B. That makes up this X. We don't know exactly where this is. Let's say our center is right there. We don't know exactly what that is, but we have A to B and C to D. We know X matches this over here because those are vertical angles. So that's also X. So it works for either way. So our angle X equals, let's go back to the slide. If you look up there, 1/2 those two angles. So it's really the average of A to B plus C to D. So the average of these two make X. Similar, if I wanted to find this one or this one, I would take the average of these two. So the average of those gives me that A plus B, AB plus CD times 1/2. We have this example. This is a good example just to sort of start off and take what we did and apply it immediately. We have a circle with a center at I. We're told this is 88 degrees. We're told this is 76 degrees. And we're looking for X right here. This is I. And I'm just copying it down here. I'm not solving anything yet. All right, here's what we got. We have I right here is where it's intersecting with 88 and 76. We know this is X as well. These are vertical angles. We don't need to worry about that. So as long as we have both of these sides represented, we're okay. So we know X degrees is going to equal the average, 88 plus 76 over 2. I'm changing my format a little bit. If you look at what we did last slide, we had this. And I hope you can see how these are the same, how we're adding them, dividing by 2, adding them, multiplying by 1/2. They're the same idea. It's just really how you want to format it. So if we have this, we're going to add those two together, 88 and 76. We get 164. We'll cut that in half, and it should be 82. 82 degrees. So once again, we were looking for X. We had to use this arc and this arc to find it. Honors people, if you want a good challenge, now find what these are. These aren't going to be too hard to figure out. This is just going to be the supplement of it, so we know this makes a straight line. So if this is 82, this has to be 98, I believe, 98. So once again, to find X, I took these two, I averaged them to get here. These are secants because they're touching the circle in two places. So we took both of those, added them together, multiplied by 1/2, 82. Similar problem, but a little bit different how we want to solve it. We have two options, really. Actually, let's just, I won't even discuss other options. Let's do it this way. So let me recreate it down below here. I hope you're doing this in your notes as well. We have cross this and cross this. (96 degrees). Hopefully you can see this one is different than the other ones. We're looking for X here, but we have these two measurements. We're looking for X here, but we have these two measurements. Well, if I wanted to find this, I can know that if I find this, either one of these, they should be the same thing, that it's going to be the complement to this. It's a linear pair. So let's call this y. I know later on, if I have 180 and I take away y, I'll find x. So if I can find y, I know x will be pretty easy. So y is going to be the average of 96 and 62. 96 and 62. 158 divided by 2. Y is going to be 79 degrees. So if y is 79 degrees, that is not my answer. I'm not looking for this. I'm looking for this angle right here. All I do is I take my total, because I know this is a linear pair. So x has to be 101. So the reason we didn't say this and this make 180 is because this is not going through the center. If it was, we could say that this arc and this arc made 180, but we did not know exactly what this arc would be. So we took this, we found a different side, we called it y for the time being. We knew y and 180 make y plus x get you to 180. We found that, put it over here. So they called it VZW. That's the exact same thing we did. They just gave it a different name. 79. And then from there, we can take away that from 180. Okay, similar problem once again, just a little bit different focus. We're not finding the average. We have the average, and we have a piece. So we have one here, one here. I know this is 60 degrees. I know this is 25 degrees. I'm looking for this. So if I know two of these, and I know this, what we're going to do is saying, I know the average. This is my other side. So what is x? Well, x, we know, has to be bigger than 60, because we know that's smaller than 60. So we know it's an average, but we could just solve it algebraically as well. So x plus 25 over 2 gets me to 60. Remember, this is our average, so it needs to go over here. These are two pieces, so they're going to go over 2. Well, I need to multiply by 2 first. And then I'm going to take away 25. So x is going to be 95 degrees. If I take 95 and 25, they should add together to get 120, cut in half, and that should be 60 degrees. So once again, we can do this with any part missing, as long as we know where to put it. We need to take the average of these two, so we need to add them together and divide by 2, and my target this time is 60. So I encourage you to pause the video, give these next couple a try. You're going to find x. If you notice you're not given the pieces where x is, you need to find this angle BEC first and then subtract it from 180. Hopefully you get 98. 98. That means this angle right here should be 72? Something like that. No, 82. 82. This one as well. Pause the video, give it a shot. Oh, Sorry, I realized you did not see that last one. So let's go back. You have this one. We got 98. You were looking for this angle first, and then you took the supplement over here. Pause the video, give this one a shot. 68, 102, form this angle. Then you'll have to take the supplement to get 95. This is your average. So it needs to be larger than 67. Another way to think about this is how far away is 30 from 67? Well, your next part is that far away from 67. If that doesn't make sense, then you can ignore it and solve it just like we did before. The answer is 104. So we have another theorem. We have a secant and a tangent intersect at the point of tangency. Then the measure of each angle formed is 1/2 the measure of the intercepted arc. Okay, so if a secant and a tangent intersect at a point of tangency, then the measure of each angle formed is 1/2 the measure of its intercepted arc. If you look here, the measure of angle 1, so here to here, should be half of your arc. Your angle is going to be half of your arc. The arc's always going to be bigger. So we have this big arc from B all the way to A. Then this angle will be half of that. So let's do this example. I'll draw it small down here. I'll draw it big down here, and we can dive into it. So we have secants and tangents. That's P. That's Q. That's R. And we're going to cut right through here. And this is 250 degrees. All right, so this is what we have so far. We know this is 250 degrees. And that means we also know what this is. This is going to make 360 minus 250. We get 110 degrees. Okay. So what are we looking for? We are looking for Q, P, S. We're looking for Q to P to S. We're looking for this angle down here. So we have this big arc, which is 250, and this angle. This angle is going to be half of 250 degrees. That's what we talked about. So let me go back and show you the slide. So we have half of the arc is the angle. So for example, this one's similar to the blue angle right here, B to A through C. We'll cut that in half to get angle 2. So we get 125. All right, we'll keep moving on. This one we have angle BCD. We're looking for this angle right here. We're looking for that angle right there. Let us draw this one out as well. If you notice, this one actually doesn't even have the other side, but we can extend this. So we see it. We have this arc being 108 degrees. So this is what we have. And we're actually looking for BCD. So we're looking for this right here. To find this arc, we need to take this and make it bigger. So our arc is always bigger than our angle. So if this angle is 108, this arc is going to be 108 times 2, which should be 216 degrees. So this arc is 216 degrees. We're looking for this, and we know there's only these two. So if I want to find this, what I'm going to do is take away, I have a total of 360. I spent 216. What does that leave me with? 360 minus 216. That is 144 degrees. Remember, our arc is always bigger than our angle. Because hopefully that makes sense because it's taking up more room on the page, so maybe that's a way to think about it. The answer, of course, is at the bottom when these animations mess up. So we get 216. We take the other side, and we get 144. So take a minute, try this problem. You're looking for FGI. That is the angle to the arc you're already given. You sort of have two options. You can either cut it in half, or you can double it. That's kind of the only two things we've done. If you double 225, you get 450, which is bigger than any angle we've ever dealt with in class. So we can probably safely assume we're not going to do that. So if we're supposed to cut it in half, we do so, and we get 112.5. We have UVW. We want this arc right here. Well, we know 99 doubles to get 198. So 198 is this arc. We don't want that. We want 162. That's what makes this a full 360. So we got this to be 198 because we doubled 99. But we were looking for this, so we take 198 away from 360. All right, I would pause the video right here, copy this down. What we are talking about now are two, we'll call them rays, are coming through or on top of a circle and the relationship between them. It's a little similar to what we did before, where we took the average of two on the inside, but now what we're going to do is subtract them and cut that number in half. So if two secants and a secant and a tangent, or two tangents, intersect in the exterior of a circle, then the measure of the angle formed is 1/2 of the difference between the measures of the intercepted arcs. If you see here, it does not matter what combination we have. If I have two secants, or a secant and a tangent, or two tangents, our equation is actually the same every time. We take our two arcs, in this case blue and red, we subtract them from each other, and then we cut that in half. Once again, we're using the same equation. This time we are just showing you all the different cases we could have. So let's do an example. We have BC is what we're looking for, and we're given E, that kind of corner angle is 62, and 141. All right. Please, please, please do not get overwhelmed. We're going to get through this together, and it's going to make more sense at the end than it does right now. All right, that's 141. We don't know what that is, and that's 62 degrees. All right, this is our problem. We have an angle here coming through. These are actually two secants, if you can see. They're going through the center, but that doesn't change our equation at all. If we had two tangents, that's okay. If we had a tangent and a secant, it wouldn't change how we go about this. So first things first, let's give this a variable. Let's call this x. If you want to use a different variable, go right ahead. Once again, this is like our central angle, our angle that's like everything's coming from, it's blasting through. What we need are two angles that we're going to use. Let me use red like they did in the previous example. So they said, all right, here's my one angle. We'll call that our red angle. Then here's our blue angle. And then here's our green angle. The basic idea is red minus blue equals, no, times 1/2 or divided by 2, either way, equals our green. That's the basic idea. So what is our red? Our red is 141, like the highway, minus, we don't know. That's actually our mystery number. It's okay. We know we have 1/2 out here that just sits out here as always. And our green angle is 62. It's like a strange average because normally with averages you add them together, but we're going to do that but with subtracting. So let's multiply both sides times 2. If I multiply by 2, I get rid of that 1/2. So cancel, cancel. I have 141 minus x equals 62 times 2 is 112 plus 4. Nope. 62 times 2. 124. Sorry. And now we can, let's move the x over. Plus x. 141 equals 124 plus x. Okay. Let's move the 124 over. X is going to equal 17 degrees. So there we go. We had our big angle, we had our small angle, we had our outside angle. We took blue away from here, and then cut that in half to get here. All right, let's try another one. So there are all the pieces we just did. If you are confused, please go on Schoology, download these, copy them down, and maybe that'll help you. All right, here's another example. We have two pieces, x, y, z, and this one's actually two tangents. W to z and w to x are both tangents. And you can probably solve this problem without doing any math and without doing what we just did. Because you know you have 140 here, and then this is what's going to complete it to 360. If you go through the whole problem, like we set it up, where our big angle minus our little angle cut in half is our outside angle, then we will get this same kind of problem. But we can also get 220. 220 makes 140 into 360. So you have two options here. You can set this up like we did before down here, or you can sort of look at this one and see. I think ones with two tangents are the easiest because you can do them more directly. So pause the video, give this one a shot. Q to S. You're looking for that small angle. It's going to be exactly like what we did just a second ago. You have 135 as your big angle. You don't have your little angle, and you have the outside angle. All right, hopefully you've given that a shot, and you get 23. We'll do this one together, actually. I'll do this one on paper. I didn't do the last one that was like this one in the notes. So we'll do this one together. You have a circle down here, kind of like this coming out. We're told this is 130 degrees, and we're told this is 50 degrees. What is this? And I want to make sure it's kind of clear what I'm talking about when I'm saying there's two ways to do it. Because there really are, and I hope you see that in both options. So we have this one, and let's see this. So we have two arcs to consider. Option number one. Option one. We just do the problem like we talked about. So our big angle, we'll call that x down here, minus 130 divided by 2 equals 50. So we'll multiply both sides by 2 to get rid of that on the bottom. So x minus 130 is 100 plus 130 plus 130. X equals 230 degrees. So I think this part, I hope you do this one. I think it's the same process no matter what kind of problem you have. But the next one I'm going to show you for this kind only. So option 2 only works. Option 2 only works with two tangents. So it only works with two tangents, like you see here. If you have secants, this won't work. But you have this. We already have 130, but the whole circle, all of our circle is being used here. Hopefully you can see that. There's no place that's not being used. If I show you one of the problems from before, you see we're not using from P to Q and from T to S. But in this case, we are using all of the circle. So I can do 360, take away 130, and that should get me 230 degrees. Once again, only works when you have two tangents. I would use this one. This one always is good for every problem you see. But if you get the hang of it and you kind of want a shortcut, option 2 is there for you still. So let's go back here. 230. We have a problem, a properties, a sort of word problem. The diagram shows the path of a light ray as it hits a cut diamond. The ray is bent or refracted, another word for bent, at points A, B, and C. If AC is 96 and S is 35, what is RBT? So we have S, we have AC, that's that arc. We are looking for R to B to T. So we're just doing a internal arc problem. This one shouldn't be too different than what we have done before. These are two secants coming through here. We're told AC is 96 degrees. We're told S is 35 degrees. And it's looking for RBT. RBT is this. So that's our mystery amount. That's all the problem is. So hopefully you can see how all this stuff is giving you, it has different rays shooting through, but it's not actually changing this problem. This problem has more things, but in reality it's just this. I cannot, in this one, use this option. I don't have two tangents. I have two secants. Even if I had one secant, one tangent, I couldn't do that. I would have to still use our normal equation. So I'll multiply by 2 again. 96 minus x is 70. Add x, 96 equals 70 plus x minus 70, minus 70. So x is 26 degrees. Same exact equation. I have my big angle, my small angle cut in half equals my outside angle. Try this one on your own. Same thing we just did. Pause the video, play it when you're ready. Okay. There are all the things we talked about. The top one on the circle. We talked about that last time, how when the measure of the arc on the circle to the outside one is half. We talked about these last two today, where the average of these two angles makes this little internal one, and then finally this subtracting and then cutting in half. So this is not new. This is just kind of like one page to summarize everything. If I were you, I would copy this into your notes, just as a little diagram to have every piece of what we talked about today. Please do not hesitate to go back over this, rewatch it again, or reach out to me if you have any specific questions. If something I said wasn't exactly clear, please let me know. I think this is going to be maybe one of the tougher sections without me being right there to explain it. I know some of you, this is hard enough, even in class, and I know this has been a stretch, but I appreciate everyone trying their best and trying to get through it. So once again, these are the three equations you need, the three kinds of things. We always think of arcs as bigger than angles. That's really a thing to kind of put in your brain, because you see in this top one, we cut that arc in half. We have in the bottom one, we take those two arcs, subtract them, and still cut it in half. Everything is being cut in half from arc to angle. I hope that makes some sense. I think that's the last thing. Yes. So please study, do your worksheets, reach out to me if you have any questions. But good luck, everybody. I will see you next video.